Hi folks, welcome to my Bit Retro Journal. If you saw my video last time, I had refurbished this Sony cassette recorder by putting two new belts on it, and then I was able to load and save onto one of these cassettes, a small, Hello World program. Since then, and then the video got kind of long, so I kind of stopped. Since then, I cleaned this up. I also used some 3-in-1 oil, which I finally found where I had stored it, and then I've also been since then just recording audio on this and playing it back. Even had some old music cassettes that I weren't that critical that I played on here. So it seems to be working. It sounds good. And what I want to do today is see if I can't load my assembler program that I wrote as in the mid '80s, because I think, if I recall, it's pretty cool. I don't have any documentation, but if I can get this, I'm sure I can figure out how to run it. So that's what I want to do today. So I'm pretty confident this is locked, that I can put the assembler program in here, and depending on how how good the tape has kept. I've kept it in a cool area, so, and always in this container. So yeah, I don't know, but let's give it a try. So load, and then the volume, and I might have to try different levels and things, but let's I'm gonna give it a try and see how it goes. So let's keep our fingers crossed if I can reclaim that. Here we go. And once it gets started, I'm not going to sit here and play it for the rest of the day. So, play it for the entirety of the... Okay, here it goes. All right. Oh. Okay, it did not load. So, I don't have the volume all the way up. So let me try... let me try a few more times to see if I can't get it to load. This might take a while because I want to go, let's see, I want to increment through different levels. So it's all the way up, and I'm bringing it back a little bit. And I'm going to increment through different levels to see if I can't get it to load. A lot of times, recollecting days of old, usually it was the level on this, because it's I did clean the head and everything, so it should work. I also ran through this cassette forward and backwards a few times to loosen it up in a new way. So let's try it again, and I'm probably going to fast forward over or skip over all this to see if I'm successful loading it. All right, so let's try it again, and let me see how this goes. And once it starts, I'm going to just skip ahead. Yeah, it looks like it's about to start. Okay, I'm going to skip ahead. Success. I got it to load. I got zeros. I just fiddled with this a bunch, but I don't think on the 5th try. But if I were to list this now, I'm just hit enter without trying to wobble the RAM pack. Yeah, so here, if I recall correctly, you have the REM statement, which you grow. I forget if there's a routine that helps you grow it, or if you had to grow it yourself. But this is mostly, I think this is 100% written in BASIC, so it doesn't have any sort of machine code part to it. Although if I recall correctly, there was a way to delete all the basic stuff, so maybe there's a little bit of a machine code loader that you can loads it into memory and then calls it. But that's just that would be just one routine. If you just quickly, I want to be careful that I don't 8120. You have LD plus LD JP JR call. They look like they're mnemonics. Hope I don't want to load it. List 8180. Oh, here the machine code set. So you have no up, LD, add with carry, sub with carry, and XOR or copy. Let's see what else this has. Ink deck plus LD. What is plus LD? Pop, push, jump relative call. Yeah. So it's got a whole bunch. 8325. Data, RST, new, dim, and end. Those seem unique. Yeah, so this has, okay. You know, the problem is I actually don't know what most of this is doing. But what really worries me now is I need to back this up because it did take some fiddling to get this on here. So what I need to do is I'm just going to that's the audio, and then I believe this is right here is the audio. Perfect. So what I'm going to do now is save it to my desktop machine. I'll just capture it as a WAV file, and hopefully, yeah, I can recover it here. And what I will do is off camera, I'll try to get it to load in the 81 emulator, and also I'm going to use OTL to create a fast load. So if I need to load it back in, I can get it into my ZX81 pretty fast. You know, I love the magnetic media, but I should rewind this. But at the same time, something like this that is from almost 40 years ago, you know, I don't want to lose that anymore, because it's sort of, I hadn't been able to successfully load it any other way. But this cassette deck certainly helped. And I thought it might, because these things are pretty decent. So let me go ahead and save it. And then also I think what I need to do is take a look at the code just to see how this whole thing works. So it's probably going to be a continuation, not later today, but probably tomorrow. It's a Wednesday, so I have until Saturday to get the video done. So either tomorrow or Friday. So yeah, let me come back. All right, I'm back. And it's been a few days. I actually was able to save it to my PC, and then load it into 81 and even create a P file out of it. I was able to print out the code. It's about 3 pages of text. And I think it takes about 8K of memory up. But I also had to sort of read the code to figure out how to use it again. So yeah, I think I know how to use it now, and I'm going to demonstrate that to you guys. It has some idiosyncrasies which are interesting, but let me show you how to use this. First of all, one thing that it wants is an end statement. So let's say if my program is going to not be, you know, over, yeah, let's just use a big number, 1,000, and everything is stored in a rem statement. So I'm just going to say end. If it doesn't see the end statement, I don't know why I did that, but it wants an end statement. I guess that's a way to only partially compile code, so I could stick the end statement anywhere. It's almost like a stop. Okay. You can see that the rem statement only has one block, and if I edit that first one, you can see that. You know, interesting enough, I searched and searched. I did not write any documentation for that. I guess that's, I was a kid when I wrote this, and kids don't like to write. So that was, I guess, what I was trying to show you on that one is that I should have gone further. There's nothing at the end here. Okay. So, so there's a dim statement. So 5 rem dim, and I can say give me 20, and what that'll do is that'll give me 20. It'll add 20 to that. It'll give me 20 more bytes. Instead of having 1, I'll have 21 bytes. And so yeah, this is cool. Let me actually write a little program. So what I want to write is, it has data statements, so you can go 10 rem data. And so this is a way to, you can do this in hex or decimal. So if you do it in hex, the way you do it in hex is you would use the dollar symbol. So you'd say, let's do 0. Hex 0 is 0, same thing. Or I can do this in decimal. Rem data, right? So in other words, I could go 255, or I could say $FF. Either one works. The hex feature only works for bytes, but let me just put another 0 in here. All right, so now I'm just adding, so 2 bytes. Let's do the first one. It looks kind of silly, but you get to use the edit features of the ZX81 Timex and 1000. Okay, so 2 data statements that are 0, and then 20. What I want in 20 is I'll do a load. Load into my A register, comma. I want to load. It can't. So you have to be pretty careful. It can't deal with trailing spaces, so you can't do this. But what you can do is it can deal with leading spaces. So in other words, you could do that. So it's not a great parser, but I recommend keeping them nice and tidy anyway. So I'm going to load 10 into this. I'm going to, just to show you, I also have the 16-bit registers. Obviously I already wrote this program and was able to run it, so I know it'll work. But yeah, this is kind of stuff that I teach to my students sometimes, but we don't use the ZX81. We actually have a simulated environment where they can learn, because it's a pretty low-level class that I teach. They can learn assembly, and it's made-up assembly. I think I use the Pippin assembler. It's a teaching assembler. Very simple, but not, we have load and store. Here you just have load, which can act in both ways. But yeah, so one feature I have is I can have a label, and then you finish that with colon, wherever colon is. That's the problem. Where is colon on this keyboard? It's right here under Z. If you want to, you can relocate. So it's going to start the code at the first part of the rem statement, which is 16514. But you can relocate your code if you want, by doing this. So I could have just said, let's say I want to start 100 bytes in. I could say equals 16614, and what that would do is it's a label, but it's also forcing the start address. And you'll see the way this becomes useful is if I want to, because there's an erase feature in here which allows me to erase the program that I've written, the assembly program I've written. I can then run it to assemble it into the rem statement, and then I can erase once it's assembled. And then, because I only have 8K of memory free, that way I can just keep erasing parts of my assembly. And then, in order not to overwrite the previous one, I can use this feature of assigning a tag or a marker like loop. Instead of saying colon, which says take on the address where you are, you can assign an address. So I think that's pretty cool. But let's go back to doing it the way and again, we're going to say just take on this address. And then we're going to say, hey, let's increment. Oops, I keep doing unplot. It's CE1. increment BC. Let's then compare BC to our accumulator. So we have 10 in A, so we're going to say CP BC, and that'll compare it to A. And then we are going to jump. We're going to do a relative jump. It doesn't actually matter because you can do an absolute jump. Either one works, but let's say jump if not 0. So after the comparison, if not 0 flag is set. And we're going to jump to loop. So you don't have to worry about, I mean, it's the one I think about assembler. You don't have to worry about like, what address am I jumping to, right? And then 50, here's where one of the idiosyncratic or idiosyncrasies of the language comes in. What I want to do is say load, and I might fix this at one point, HL, HL, and comma BC. So I want to load into memory address HL, which is one. Did I assign it? Oh no, right. This is. I'm sorry. I'm one ahead here. I want to actually. So 50 is going to be load HL with 16514, which is the first byte in the program. And then 55, I want to then say, then take BC and load it into the address that HL has. That's what this designates. So load BC, the thing that you've just kept incrementing until it ends up. So again, if you only jump if it's not 0, but as soon as BC, the comparison between BC and A is equal, then it's not going to jump back to the loop, which means that BC has 10 in it. We set the HL register to the address of first byte, and then we're going to move BC into it. And then the final one is going to be 60 halt. And that says halt the program. Oops. I hit enter too soon. Okay. But that will not work because of one of the idiosyncrasies of this program, which is that most of these are 2-byte instructions, but there are 3-byte instructions, and those are the ones dealing with addresses. So call, jump, and then one form of LD, load. And because I was I guess as a kid, I was like, I don't want to have to deal with that. And so the way you solve that is, that's what the plus is about. So this tells it that this is a 3-byte load versus a 2-byte load. And I should be able to figure that out maybe by the address, if the address is greater than 255. But yeah, so I might fix it if I end up wanting to publish this. But there's our program, and this actually will loop 10 times and modify the first byte, which right now looks like a little inverse space, to be 10. So let's run it. This is going to assemble it. It actually goes pretty quick. The flashing stuff is just at the TV when it doesn't have when the ZX81 is in fast mode. The flashing stuff just is part of the TV. And on an old CRT, I think it would just be black. Okay, and then when it comes back with a 0, we're successfully assembled it, and you can see now the REM statement has changed. And if I go print peak 16514, you'll see that indeed 0 has been put in there, and that's exactly what the first data statement says to do. Okay, now how do we run it? Well, generally, I would run it with a rand user 16514, except I have those two data statements. And so the way I run this instead, I could actually put a like a tag in there if I want it. The reason why is if I print out my table, which is, you'll see that it has loop as 16520. So it'll just create a list of comma separated variables equal to their addresses. So if I wanted to, I could have just put another tag or label, I guess, right after the data statement. So like it's 17, I could have said rem start, and that would tell me what the start address is. I couldn't use start in rand user because the labels in the assembler don't translate into ZX81 basic variables, but at least I could then print the table out, which is in T. There's another table, F, which I'm not sure what that is. Haven't figured that part out yet. It's maybe for forward looking. Yeah, so it's empty right now. So the only thing that has it is T. So there's two tables, T dollar and F dollar. So I think F dollar might be forward looking. So if if the loop were after and you're jumping in this direction, but again, I haven't experimented with this enough yet. Okay, so let's run it. So we're going to say rand user 16516 and should go pretty fast. Bloop. And you'll see now that the rem statement's first element has changed. And if you go print peak 16514, da-da, we have 10 in there. Look at that. That's pretty cool. And so, yeah, the program works. Now, if I want to get rid of this, the thing is, the dim statement is going to keep adding to this. So once you have the size, what you can do is just, I need to add a comment that doesn't exist yet. So maybe like if there's a semicolon, maybe you should know everything. So the way you just get rid of that for now, since you don't have to dim it again. And if I want to, if I'm happy with this program, what I can do is at the for 1000, I can just replace it with I can just say erase. And what that'll do is it's going to recompile it again. So and yeah, so I'll just show you if I did it this way instead, what I can do, of course, is I can just say 1 rem 9 space. So that's one way to delete the actual machine code program you just wrote. So then I probably want my dim statement again. It was 20. The other thing I found in here is that there are places where I could do this. I don't know if I did this for the dim statement, so I could do this because in the code there's literally a line where it says if there's the parentheses, just strip them off. So maybe I did it. So I'm not sure, it's kind of unnecessary then, but I'll do that. But if I run this, what's going to happen is it's going to create the program, and then at the erase, it's going to delete everything between after the fast and the erase included. So now if I run this, you'll see that I'm going to get the same program back. And come on. It's actually not too slow. I mean, it is written in BASIC. It's running in fast mode. And there are, yeah, so if I do this, it's its own fast mode, but you can see it got rid of, I can do slow, wherever slow is. I forget where slow is. Slow. You can see that the program is loaded, but now I got rid of the all the assembly. And if I'm really done with my program, then I can also do the following. I can say 5 rem new, and what that will do, if I run that, so it's all written in BASIC, except there's 3 machine code programs. So now all I have is that left, and so then I could literally again, I'm going to get back to slow. I could literally so I could say 2 rand user 16516. And so now I have my pure machine code program. I could save it and I could, do what I want with it. So yeah, it's pretty in there. So if I run this now, this will literally run and change the first byte. You can see it's changed again. So yeah, so that's pretty cool. So it has lots of cool features. Again, I wrote this in the mid 80s as still in school as a kid. And it's actually pretty good. And so I still need to look at whether it has some bugs in it or not and try out different things. Let me show you one more program, but I think I'll fast forward over that. Okay, I'm back. And so I just entered this program, and I actually got this program from a video on YouTube where some guy was reviewing the bug byte assembler, which was a professional assembler written back in 81, 82. And they put this program in, and I'm like, oh, I'll try it. The only difference is that for the call, they had a hexadecimal digit and for both calls. And so they had a hexadecimal 10 for the second one, and the first one, I forget what it was, 05 something. Except my hexadecimal can only do a byte instead of not 2 bytes. So you can translate it into decimal, so that works. But what this does is it's supposed to print a little character in the middle of the screen. So let's run it to actually assemble it. And then it actually works. It does exactly what the person had. They also had a longer one that was a game that they were writing, although theirs wasn't working. So I do want to try to see and type in a few. So here it is, and if you run it, so this one you're going to do rand user 16514 since there's nothing in front, and this will, bloop, yep, just put that character right there, line 5, column 10. So I thought that was cool that I was actually able to take someone else's program from a different assembler and it was able to run it. So yeah, this is written fully in BASIC. Like I said, there's a couple of machine code programs, and I'll show you what they look like real quick. Because they're just pretty easy. Yeah, so 8910. So basically I store them as here are both of them. So I store them, I poke them in, and then I call them with a rand user 1644 call. And the first one, one of these adds memory. I think that's the second one. And then the first one erases or new. Yeah. So these are little routines that I just poke into memory address 1644 and just run them from there. And that helps me out. But other than that, everything else is basic. So anyway, that's my assembler. I will maybe put it on GitHub or somehow to the public domain, but I want to first tweak it a bit more. And yeah, written fully in BASIC, so it's different from the other ones. So the one negative is when you have a assembly program, you have to save it and the assembler, which is 8K, so it takes a little bit of time. But if you actually, the way I loaded this in now is I use OTLA fast load, and it's actually kind of nice. So I'm going to end here. Thanks for joining me. Thanks for letting me share this assembler that I wrote as a kid. I'm super happy that I was finally able to retrieve it and learn again how to use it. I think it's pretty cool. Let me know what you think. Maybe also improvements I could do, like for instance, maybe adding comments to it. That idiosyncrasy with the plus LD, I don't know how to fix that easily. It would, because you don't want to make the assembler that much bigger. You want to keep it sort of 8K or less. So I'd actually like to shrink it a bit to give myself more room. But I think this reminds me a little bit of how MCODER worked, which was one of my favorite compilers, basic compilers that the ZX81 had. So yeah, I kind of wrote something as a kid that was similar. All right, I'm going to end here. Thanks for joining me, and I'll see you next time.